This video is going to show how we can use molarity as a conversion factor in doing some calculations. We're going to look at a couple example problems. This first one asks us to calculate the grams of potassium nitrate needed to prepare 2 liters of a 1.5 molar potassium nitrate solution. So in these types of problems where you are given the molarity and then you're asked to either find volume or an amount of the solution or the solute, you're going to start with the amount that you're given. In this case, the amount we're given is our 2.00 liters of solution. We are not going to start with the concentration for these types of problems. So let's start by writing that down. 2.00 liters of our solution. And then we're going to use our molarity to convert between moles and liters. And so a 1.50 molar solution means that you have 1.50 moles of potassium nitrate in every 1 liter of our solution, potassium nitrate solution. So I'm going to write 1 liter of solution on the bottom and put 1.50 moles of potassium nitrate on the top. The liters cancel. And now we have moles. Our problem is asking for grams, and so we can use the molar mass to convert between moles and grams. And we get the molar mass for potassium nitrate from the periodic table. And so 1 mole of potassium nitrate is equivalent to 101.1 grams of potassium nitrate. Our moles cancel. And we're left with the units of grams of potassium nitrate, which is what we are looking for. So we'll go ahead and solve this problem. We'll multiply 2 times 1.5 times 101.1, and we get an answer of 303.3 grams. Now we want to round to significant figures. So in this problem, 3 significant figures is our lowest measured number. So 303 grams of potassium nitrate is our solution to this problem. Now, if we go back to the problem, it's asking us to calculate the grams of potassium nitrate needed to prepare 2 liters of a 1.5 molar potassium nitrate solution. So if you actually had to prepare that solution, you would first start by doing this calculation and find out that you need to measure out 303 grams of potassium nitrate. So you'd go to a balance and you would do that. You would pour this into a 2-liter volumetric flask, and you would add water. You would add some water to it, stir it up until all of the potassium nitrate dissolved, and then add enough more water until you get right to 2 liters, and then continue to make sure you mix it up properly. But that would be how you would actually prepare this solution. Let's look at one more problem. This one says to calculate the milliliters of a 3.0 molar sodium chloride solution needed to obtain 0.65 moles of sodium chloride. So again, we're going to start with the amount that we are given, which is our moles of sodium chloride. We are not going to start with a concentration. And so let's start by writing that value down, 0.65 moles of sodium chloride. We need to calculate milliliters, and so we can use our molarity to convert between moles and liters, and then we'll do one more conversion to get to milliliters. So a 3.0 molar solution means that you have 3.0 moles of sodium chloride and 1 liter of solution. So in this case, our 3.0 moles of sodium chloride will go on the bottom. 1 liter of our solution is going to go on the top. And so one last conversion. Let's see, well, let's cancel out our moles right here. And then we just need to convert to milliliters. And so we know that 1 liter is equivalent to 1,000 milliliters. Okay, so now we can just solve this problem. Our liters will cancel. So we take 0.65 times 1,000 divided by 3, and we get an answer of 216.7 milliliters of sodium chloride solution. We need to round it to significant figures. We have the lowest measured significant figures is 2, so we need to round this answer to 2 significant figures. So it becomes 220 milliliter of our sodium chloride solution. Okay, so those are just a couple example problems of how you can use molarity as a conversion factor. Remember, molarity, our definition is it's how many moles are in a liter of something, and so we can use it to convert between moles and liters.